Let's take a look at the fundamental quantities in physics: position, distance, and displacement. We'll start with position. It's a way of indicating where an object is located. The ways we can do this is by drawing a number line or a Cartesian coordinate system. So let's do an example. Line. It will be a line with numbers labeled on the line. And let's take an example of an object at the point 2. For in this case, we'll label the position as 2 meters. If you look at the Cartesian coordinate system and y-axis, let's label the axes. Let's say an object is placed at this point. It's at x is equal to 3 meters and y is equal to 2 meters. So we're looking in two directions. Now let's look at distance and displacement. Before we talk about it, what it means, we can take an example of from school to home. Let's say we're going from school and we traveled 3,000 meters, then we went home and we traveled another 4,000 meters. So distance is defined as the length of the path that you have traveled. And displacement is the change in position, or how you changed your distance by adding 3,000 and 4,000, that's 7,000 from the school to the home, in order to figure out the displacement or the change in position. Find the displacement, we need to find that side of the triangle. If you remember from your math class, this is the right angle triangle, and to find the hypotenuse of this triangle we need Pythagorean theorem, which is a square plus b square, which is equal to c square. So let's take the sides of the triangle as a and b and plug in the numbers: 4,000 squared plus 3,000 squared, which is equal to c squared. Then at the end we have to take the square root of what answer you get, and the answer is 5,000 meters. And what categories they fall into: distance is a scalar quantity, displacement is a vector quantity. What is scalar quantity? What a scalar quantity means is that it's only going to be represented by its size or the magnitude. For vector quantity, we need both magnitude and the direction. So with magnitude, what it means is that you need the number and the units for the final answer. For vector quantity, you need the number, unit, and the direction as well. Now, what direction do we state? To answer this, it's easier to understand to use the language that is used in the problem. What I mean by this is that if the question or the problem says or uses the directions as north, south, east, and west, in that case, your answer should also be stated in the same direction terms as north, south, east, west. If the problem says left, right, up, or down, in that case, you're going to follow the same rule and state your answer with the same given question direction. Let's look at some examples. Let's say a dog is traveling from a point, let's label it as start, and it's going to another point, let's label that point as end. Let's say the path that the dog followed is as shown in the picture. It traveled 5 meters first, then 8 meters, and then it went 5 meters again. So if we calculate the distance traveled by this dog, we're going to add all the numbers to figure out the length of the path. And the change in position is from start to end. So if you connect those 2 points and direct it towards the end, we can see from the picture that it's to figure out the direction, north, south, east, west. We can say that the displacement is towards east. Here's another example. Let's say we have an elephant this time. Let's draw the coordinate system x and y axes. Let's say it starts from the start and goes to the end point as I labeled in the picture, and it's traveling to this path 20 meters and then 15 meters. The distance is obviously adding the two numbers. That's the length of the path. Displacement is how far from start to end. In that case, we have to use the Pythagorean theorem. Treat it as a right angle triangle. Find the hypotenuse of the triangle using the Pythagorean theorem. A squared plus b squared is equal to c squared. And then don't forget to take the square root at the end. The final answer is 25 meters. Now let's talk about the direction. We need to identify the angle. So we're going to use the trig functions. So Katoa, if I label the triangle as opposite side and adjacent side, I can find the angle using the tangent function. Again, use the numbers in your triangle. If you take the inverse of tangent, you will get the final answer, which is going to be 36.9 degrees. So I can state my displacement as 25 meters at 36.9 degrees from the negative x-axis. Now, if we look at the tools to analyze the motion of an object, we draw sketches, we draw diagrams, we plot some graphs, and we also use equations to describe the motion of an object.